Okay, guys, if you're watching this video, it is part 2, numbers 6 through 10 of compound probability practice. So if you haven't seen part 1, you want to go back at this time and watch numbers 1 through 5, and then we will continue now with numbers 6 through 10. Okay, so number 6 says, in an experiment, a 6-sided die is rolled a number of times. The results are shown below. So it says, based on these results, what is the experimental probability of rolling either a 2 or a 3? Well, if we look at this, it only says it's rolled a number of times, and we don't know how many times that is. So we need to total that up. So let's add these up. 4, 8, that's 6, that's 18. Plus 7 plus 3. So that is a total of, if I'm not mistaken, 35. I'm just going to write total over here to give it a title. So the total amount of times that this 6-sided die was actually rolled is 35 times. We're trying to find the experimental probability of rolling either a 2 or a 3. We were used to the word and in the other problems, but this is the word or. So the symbol for using the word or instead of writing the word is an upside down U, whereas the word and was, I'm sorry, is a right side up U, whereas the word and was an upside down U. Remember from the other ones, and looks like this, so or looks like that. Okay, so we're looking for the probability of a 2 or a 3. Okay, so because the 2 and 3 are different numbers on a die, and you can't roll both of them at the same time, you can only roll a 2, or you will be rolling a 3 or another number. We're going to find the probability of a 2. And we're also going to find the probability of a 3 because this is together. So the probability of rolling a 2 is this many times, 8 out of the 35 times for the chance of rolling a 2, and then we want to include the probability of the 3, which is 6 out of 35 times. This number here. So we want both of them because it's this or that. So we'll add those together, and we will be getting 14 out of 35, which if you simplify that, that would be, they're both divisible by 7. So that would be 2 7s. I'm sorry, 2 5ths. Is answer A. Okay, good. A couple new concepts there. Hopefully, you need to review that. You go back again and listen. Okay, moving on, number 7. We have Sam's closet contains blue and green shirts. He has 8 blue shirts, 7 green shirts. 5 of the blue shirts have stripes. 4 of the green shirts have stripes. What's the probability Sam randomly chooses a shirt that is blue or has stripes? A lot of info going on here. We have shirts that are blue. We have shirts that are green. We have shirts that have stripes. And we have shirts that don't have stripes. So I like to make an array for this so I can keep the data organized. So I'm going to write stripes and no stripes, and I'm just going to create that array. Okay, and in addition, I'm going to want to put a total maybe here because we have probability, so everything has a total when we talk about probability. Okay, so let's put these numbers in. So how many of the shirts are blue with stripes? Well, we have 5 of those. How many are green with stripes? It says 4 of the green shirts have stripes. So I'm going to put 4 there. And again, it's the reading. So you have to go back and look at the numbers in the word problem. So 5 and 4 makes a total of 9